So hello friends, in this video we are going to discuss our Leetcode Biweekly contest 136. Basically it's a medium level contest. So now let's discuss our first problem. Our first problem is what? Find the number of winning players. Basically you have been given an integer n. Integer n over here is basically the count of the players over here. Okay. Then you have been given an and 2D array pick over here containing of x and y. So basically, X represent what? X represent the player, and the Y represent the color of the ball picked over here. Basically, this is the pick, and this is X over, and this is Y given over here. So basically, player zero can pick any one ball. Player one can pick what? Player one can pick two balls. Player n can pick over n plus one balls. Okay, means player one can pick two balls means 1 plus 1. Player 2 can pick 2 plus 1, 3 balls. Okay, so in this way, player I wins if they pick at least I plus 1 ball. But for all balls where they have to pick of same colors. Means 2 ball of same color, 3 ball of same color over here. Okay, so this is an edge case. You have to keep this in mind over here. Okay, so now let's discuss the approach over here. What kind of approach you are going to use in this type of problem statement? And by discussing a simple example also. First of all, we'll take a single example. Basically, n is given here 4, means 4 players are playing over here, means they are going to play the game. Let's draw the array over here. Let me copy it from here only. Okay, so basically this is the array we have been given, 2D array, and n we have been given as 4 over here. Okay, so the zeroth player, basically the zeroth player over here is going to means basically we have been given the zeroth player. He has taken what? He has taken zero ball over here. Okay, he has just picked zero balls in this game. Okay, means zero ball of we can say, or we can say a ball of color zero. Okay, this zeroth player here has taken a ball of zeroth color. Zeroth player has picked a ball of zero color. This is what color, and this is count over here. Then first player has picked two balls. Okay, the first player has been given of how many times? Two times we have been given. So basically, I have picked the ball of zero color two times. Okay, two times. Hmm. Let's correct it. Let's make here count and let's make it player over here. Okay, so basically the count of zero is what? One. Okay, so basically, then second player over here. Second player. The player number second. How many times he have played? Three times. But how many colors he has used? One color and zero color. Means two times one color he has used and one time zero color. Okay. So basically the two player is not playing a valid game. Means he is not winning the game. Okay. So basically in this game what we have to do? We have to use all the same color throughout all the game over here. Okay. As the player zero over here. As the player 0 over here has played one times but he has used only one color of 0. Okay, then player 1 over here, he has played two times but he has used color 0 only. Okay, so for example like 1 3 1 3 over here. Basically, the player 1 has played 2 times over here. The count is what? 2 times. Means one is the array is given here 2 times in the big array. So basically, he has played 2 times. So means I is what? I is 1. So he has played I plus 1 times. Means it is correct over here. Means 2 times he has played. I plus 1 means 2. 1 plus 1 equals to what? 2 over here. But now see the color. Color is what? 3 3. Okay. As you are able to see in both the games, we have same got the same color. Means player has used the same color throughout the whole game. Means 1 is the winner. So our count will increase by 1. Okay. We have to return the uh, number of players who will win the game. Okay. So basically, let's discuss our next example over here. We have been given number of players as 5 over here. Okay. We have been given number of players as 5. Okay. So n is what? 5 in this case. Basically, the 5 players are playing the game. Okay. So in this game, uh, uh, we can say what? Player, color. Okay. Player 1 and count over here. Count how many times the one player has been given? 1, 2, 3, and 4 over here. Okay, we have been given 4 times. So basically, our count will be means how many times does the player 1 has played the game? 4 times. And color is what? 1, 2, 3, and 4. Color used in this in each game is what? 1, 2, 3, and 4 means different colors. We have to use only one color evenly. So our output will be what? 0 over here. As only player 1 has been played the games. Not 2, 3, 4, and 5 player have played the game. And the color is also different over here. So basically, this is not a valid and means player 1 is not able to win the game. He has failed. Okay. So next example is what? We have been given number of player as 5 over here. And basically, the okay. Basically, we have been given number of player as what? 5. And we have been given an array. So first of all, let's form our count, then player, and then color. Okay. Basically, the count, player, and color. Basically, first of our player is what? 1. Player 1. How many times player 1 has played? He has played only 1 time. So 1. And color is what? 1 over here. Basically, as you are able to see that the player 1 has played only 1 time. The count is what? Only 1. Basically, we have the rule of player 1 must play I plus 1 time. So basically, player 1 must play 2 times. So basically, the count is what? 1 only. So player 1 does not win the game in such case. In this case, player 1 is not able to win the game. Then move forward to this. Moving forward to this. Okay. Player number 2. So player number 2 is present. Player number 2 has played how many times? 3 times over here. Okay, player number 2 has played 3 times. Means I equals to what? I plus 1. 2 plus 1 equals to what? 3. Means count is absolutely correct. Let's see the color. Color we are able to see in all the 3 games. All the 3 games, color is what? 4 over here. Means color is been same in all the 3 games. Basically, this case is what? Valid over here. As you are able to see, this is I and this is I plus 1. Okay, and color is what? Only single color has been used in this game. So basically this is correct and our output will be what? Our output will be 1. Means only one player is able to win the game in this case. Okay, so now let's try to understand with the help of the approach what kind of approach we are going to use over here. Let's see. We are going to use a simple dictionary over here. Okay, we are going to use a simple dictionary in this case. So now let's discuss about it. Okay, so basically, we will use a simple dictionary over here. For example, let me write the code also. It will be more easier to understand. Okay, so we will use ball count. Initialize our ball count to what? Default depth. Default depth of what? Integer value. All values are what? Integer over here. Okay, default depth of int for in range. Uh, in range n over here. Okay. So basically we have created a dictionary over here to count the number of balls of each color. Okay, for each player. Okay, basically it will be ball count of 0. Basically it will be what? Ball count of 0 equals to what? Is for player 0. Ball count of 0 is for what? Player 0 we can say. Similarly, ball count of 1 is for player 1 over here. Then ball count of 2 is for player 2 over here. Okay, in such case, here this dictionary is used to help us. Okay, let me initialize it, write it. Okay, similarly, we have been given, yes, now it's correct over here. Okay, so basically we have created a dictionary over here. In this case, we have been created a dictionary. Then, let's suppose take an example. For example, let's take n equals to what? 3 over here. Okay, let's take some kinds of example. Okay, basically we have been taken our n equals to what? 3 over here. For example, and then we have taken our 2D array. 2D array of what? 0, 1. For example, I am taking 0, 1, then 1, 1, then 2, 2, 0, 1, 1, 1, then 2, 2, 0, 1, and then 1, 1, 2, 2, 0, 1. 1, 1, 2, 2, 0, 1. Okay. Okay, now it's correct over. We have been taken a simple example over here. I have taken. Let's give it some spaces for easy understanding. Basically, over here, as you are able to see, we have been given n equals to 3, means 3 players are going to play the game. So, from the observation over here, you are able to see 0th player has played 3 times. 0th player has played 3 times in this game. Okay. One player has played only one time, and two player has played what? How many times? Two times. Basically, this dictionary ball count dictionary over here has created a ball count of 0 for player 0, means ball count of 0 is for whom? Is for player of 0. Similarly, ball count of 1 is for whom? Player of 1. Similarly, ball count of 1 is for player 1. Okay, so as you are able to see over here. So in this case, we have been given n equals to what? 3 over here. So it will be 2, means 0, 1 and 2. Okay, ball count of 0, 1 and 2 over here. So as you are able to see, now we have been creating a has one, okay, a list called has one over here to track if each player has one or not. Okay, initially all players have one. Okay, so we will initialize it as false, means no player has one up till now. Then we will update the value now in the iteration over here. Okay, this is a simple brute force solution. Okay, so we will initialize false over here. False multiplied by n. Okay, false multiplied by n over here. N is what? The number of players. Okay, so basically he has one. Has one will be what? Has one will be equals to 3 times false. Okay, we have been given or taken a has one called list over here, initializing 3 times false over here, means n times false, means no player has won the game up till now. Then we will process the peak over here. Okay, means for each player in the peak, means for each player and color, we will update the count of the color for the player and check if this player wins. Okay, so basically for p in what peak over here, we are iterating through the array for p in each element through the array. So basically player comma color is initialized to what p over here. Okay. Then ball count will ball count of player comma player of means we can say player of color is incremented by one. Ball count of player of one. Okay. We have been incrementing it by one over here. Why we are incrementing in it by one means if a player wins, they have clicked the player plus one. Okay. The balls of the same player. Okay. So we have been incrementing this by 1 over here. So first of all, we will pick 0, 1. Okay. Then let's see. First of all, the player will pick this 0, 1 over here. Okay. Pick 0, 1. So our, let's suppose ball count of what 0, 1 becomes what? It will become 1 over there. Okay. Means player 1 needs 2 balls to win 1 plus 1. So has 1 equals to what? Remains false over here. Our has 1 equals to what? False in this case. Okay, now pick ball count of 1 comma 1. Okay, ball count of 1 comma 1 over here. Basically, ball count of 1 comma 1. It will be what? It will become 1 in this case. Okay, means player 1 needs 2 balls to win the 1 plus 1. Okay, so has 1 will remain false in this case. Okay, I am using some short forms over here so that it will be more easier for me to write over here. So please manage. Then then our ball count will be what? 2 comma 2 over here. Our ball count will be 2 comma 2 in this case. Now, so basically our ball count of 2 comma 2 will become what? It will become 1 in this case. Means player 2 needs 3 balls to win the 2 plus 1 game. Okay, so has 1 remains what? Has 1 remains false in this case. Okay, then our pick will be 0 1. Our peak will be now 0 1 means ball count of 0 1. Ball count of 0 1 which will become 2 over here. Okay, means 0 1 we have encountered 2 times in this case, means first 0 1 and this is second 0 1. Okay, so now has one has become what? Has one has become true. Okay, means the player here 0 needs to play what? One ball to win the 0 plus 1. So has one will become what true over here. Has one will become true in this case. Okay. Then our peak will be what? 1 comma 1. Our peak will be 1 comma 1. Means ball count will of 1 comma 1. It will become what? 2 over here. Means player 2 needs 3 balls to win the game. Means 2 plus 1 game. So has one will remain what? Has one will remain false only in this case. Okay. No, no. Sorry. Has one will become true. Has one will become true. Means we have encountered 2 games for 1 player. Okay. So it will become true in this case. Then we will encounter the 2 comma 2. 2 comma 2 of. The ball count will become what? Ball count will become ball count of 2 of 2. Okay, it will become what? It will become 2 over here. Means player, but player 2 needs how many balls to win the game? Player 2 needs 3 games. Okay, 3 balls to win the game. So has one will become, will remain false over here. Has one will remain false in this case. Okay, so basically now pick 0 1. Pick of 0 1. Okay, then ball count will become what? Ball count of 0 1 will become 3 over here. As basically we have already become true over here in this case. Means what? Has one has already become true, then also it will remain true only. So we have encountered how many truths over here in this case. Basically we have encountered this uh, ball of 0 comma 1. This we have encountered this 0 comma 1 and 1 comma 1. Okay, so basically our winners will be 0 comma 1 and 1 comma 1, means 0 and 1. So basically two players have won the game over here. Okay, two players have just won the game in this case. So now we will do what? We will do the simple return statement. Means winners will be what? Our winners will be just be incremented by 1. Okay. So has one player will be become true over here in this case. So basically, as we have done the players who have won over here, true. Okay, if they meet the ball count condition, okay, we will make them true over here. Basically, this I am trying to this over here. If if the ball count, if the ball count of player comma color, if the ball count of player comma color is what, is equal to what, player plus 1, means player 0. Okay, player plus 1 over here, means what does this mean? It means 0 will have 1 over here. Okay, basically the 0 will have what? 1 over here. 0 player will have 1 ball, then 1 player will have 2 in this case. So in this case, will run the if statement. Okay, then what we will initialize the has one of each player true if it meet the condition. Okay, if it meets this condition, we will initialize it to true in this case. Means has one of what, has one of player are equals to what, it will equals to true in this case. Okay, so it is initialized to true over here. Then what, then we will return the sum over here. Okay, sum we can say. So basically winners equal, our winner count equals to what, winner count equals to sum of has count, means the number of trues over here, number of true over here. So we will return just the winner count. return winner count. Wait a minute. Okay. So now let's try to run the code one time. It's giving some pair where it is pair. Okay, this one. Okay, sorry. Basically has count is not defined ball count where it is has one. Okay, sorry friends. Must be has one over here. Okay, sum of has one. Yeah, it's now running successfully. Now let's try to submit it. It's being accepted over here. Okay. So basically your code is being accepted over here in this case. Now let's move on to our next question, means next problem statement. Yes. So basically our next problem is minimum number of flips to make binary grid palindromic. Part 1. It's a part 1 question, means next question is also given over here. But I was able to solve only two questions in this contest. So it's okay. Let's discuss this question only. So basically we have been given an m into n grid over there. We have been given an m into n grid in this question. Okay. So what how we will solve this question? Okay. So basically what is a grid? Let's discuss. This is a grid. Means 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. This is the basically number of rows, and this is what number of columns over here. This is n and this is m, means m into n grid over here. Okay, m rows and n columns. This is what 3 into 3 grid. Okay, 3 rows and 3 columns. As you are able to see, this is a m into n grid over here. So basically, a row or column is considered palindromic if its value read the same means forward and backward. Means what is a palindrome number? Let's discuss one time. What is basically a palindrome number? 1 to 1. For example, 1 to 1. Is it a palindrome number? Means if you're reading from left to right, if you read from left to right, it is what? 1 to 1. And n. If you read from right to left, it is what? Also 1 to 1. Means it is a palindrome number. But for example, 1 to 2. If you read from left to right, it is 1 to 2. But if you read from right to left, it is 2 to 1. Okay. So basically, this is a palindrome number. Oh, wait. It is 2 to 1. Okay. So basically, this is a palindrome number. Means 1 to 2 is not a palindrome number, but 1 to 1 is palindrome number. Similarly, like 100. If you read from right, means left to right, it is what? 100. Okay. But if you read from right to left, it is what? 001. Means 100 is not equals to 001 in this case. So basically, it's not a palindrome number. It's absolutely not a palindrome number. But for example, if we take 101, if you read from left to right, it is 101. Also, if you read from right to left, it is what also 101 only. Okay, so basically 101 equals to what? 101. So this is a palindrome number. Okay, so basically we have been given a binary grid, and we have to flip the number of cells in the grid from 0 to 1 or 1 to 0. Means we have been given a binary grid either in the form of 0 or in the form of 1 over here. So we have to return the minimum number of cells that need to be flipped to make either all rows palindromic or all columns palindromic. Okay, means either the column must be palindrome, means 101. Okay, or the row must be palindromic, means 010 we can say, or 101. Means all the row must be palindromic or all the columns must be palindrome. So basically Let's discuss with an example. You have been given a binary grid, we can say. Okay. So this you have been given 1 0 0, then 0 0 0, and then 0 0 1. So basically, what does the uh, palindrome row, all rows palindrome or all column palindrome means? You have to flip either means numbers, or we can say cells to either 0 to 1 or 1 to 0 to make it palindrome. So let's flip this 0 to 1 over here. So this will become what? This will become 101. As you are able to see, either reading it from left to right or right to left, it is 101 only. So this is a palindrome number. Then we will flip this 0 to 1. Okay. So now after reading this 101, it is also a palindrome number. And then 000 is also a palindrome number. Means reading from left to right or right to left is same over here. Means 000 or 000 only. So basically, we are able to see that all rows are what palindrome number in this case. Basically, our new grid will be what? Our new grid will be 101. Wait a minute. Our new grid will be 101, then 000, and 101 in this case. Okay, so this is basically a new grid. So in this case, how many changes you have done over here? In this case, how many flips you have done? Basically, the two flips you have done. Okay, so our answer will be what? 2 over here. Now let's try to discuss another example over here. Yes. So basically, I've been given grid 0 1 0 1 and 0 0. This is 0 1 0 1 and 0 0 over here. So you have to convert it to what palindrome number means either all rows must be palindrome or either column must be palindrome. So basically, let's convert the columns to palindrome means these columns. Okay, we have been given two columns over here. So now let's convert the columns to palindrome. So in this case, the columns are what? 0 0 0. If you read it from left to right or right to left, it is what? 0 0 0 only. So means this column is palindrome. But this column, it is 1 1 0. If you read from left to right, it is 1 1 0. But if you read from right to left, it is what? 0 1 1. Means both are not equal over here. So basically, this was first and this is second now. So basically over here, as you are able to see that the second row, second or we can second column, sorry, second column is not palindrome. So what you have to change in this 1 1 0 to make it a palindrome. So let's flip this. Let's flip. For example, you can flip 0 over here, or you can flip either 1 over here. Means you can flip either this 0 to what 1 means 1 1 1. Okay, or you can flip what or let me write here. Okay, or you can flip this 1 1 0. So this one you can flip to what 0 1 0. Anything you can do. Okay, anything you can do. But both the numbers are what palindrome only. So anything you can do over here. So basically your all columns will be what 0 0 0 and 1 1 1. So basically all columns are what palindrome over there. So minimum how many flips you have to do? Only one flip you have to do. This is basically or one. This two are you are able. This is your or one. Okay. Either you can flip last one or you can flip first one over here to make it palindrome. So columns we have been completed. Now rows. Rows are what 0 1 0 1 0 1. So as you are able to see that each row you have to be converted to 0 0 or 1 1. Okay, this must be 0 0 or 1 1. So also this must be 0 0 or 1 1. So in this case, how many flips you have to do? Total three flips you have to do in this case. So means as you are able to see, to make it this one 0 0 0 0 0 0 or 1 1 1 1 1 1. So in this case you have to do three flips, but in first case to make all rows palindrome, but in first case you have to do only one flip over here, only one flip over here. So basically minimum is what? One over here. So our answer will be one only. Okay, means we have to do what? Flip only, means either make column palindrome or make row palindrome. Our minimum flip is in column only. So we will do the column flips. Okay. So now let's discuss the approach over here. What approach we will be going to use in this case? Basically, we are going to use a simple approach. We can say simple approach. First of all, let's iterate through the grid over here. Let's start the first of all solving of approach. Then we will discuss it. Let our m will be what? Length of the grid. M is what? M is basically is the number of rows in grid. M is number of rows in the grid. Length of grid. M is length of row in the grid. Length of row. Okay. Then n. N equals to what? N equals to grid of what? 0 over here. Basically, this is what? This is the number of columns. Let me, instead of writing length of row, write number of rows, and this is what? Number of columns. Okay, so basically this we have initialized the m and n, means number of rows and number of columns. Then we will initialize our row flips. Okay, our row flips is initialized to what? Sorry, let's initialize our row flips to 0 over here. Means this is the count of the number of flips we are going to do in the row. Then we will iterate through each row for I in range m over here. For I in range m, we are going to iterate through each row. So our row flips will be incremented by what? The self dot count flips, means we are going to call a function over here. Basically, we are going to call a function self dot count flips. We can say self dot count flips of what? Grid of I. Grid of I means each row. So first now create a function over here, def count flicks. Def count flicks of what? Self comma arr. Self comma arr means array over here. Okay, so basically let's initialize our n as the what? Our n as length of the array. Our n is the length of the array over here. Then our initialize, let's flip over here. In this case, flips is what? 0. Flips equals to 0. Then if, then we will run a for loop for I in range. For I in range n by 2. Till n by 2 we will run it. Okay, for I in range n by 2. If arr of I not equals to what? Arr of n minus I plus 1. N minus I plus 1 over here. If both are not equal. Okay, if arr of I not equals to arr of n minus I plus 1, then we will do what? We will increment our flips. Our flips will be incremented by what? 1 over here in this case. Then we will just return our flips. Simply return our flips over here. Okay. Okay, we have called the flips over here. Then we will run another for loop over here. We will just run another for loop. First of all, increment our row flips. Row flips plus equals to cell dot count of count flex grid of 5. Okay, we have incremented over here. Then we will initialize our column flex. Call flex we have initialized towards 0 over here. Then we will run a for loop for j in range, n over here. Then we will initialize our column. Column equals to what? Column equals to grid of ij. Okay, for I in range m over here. Basically, what is the meaning of this column flex? Means what I have done over here means accumulate the number of flips required in column flex over here. Okay, for I in range m over here means for each row we have initialized the column over here. Okay, call equals to. Then we have incremented the call flex plus equals to, incremented our call flex cell dot what call count of flips cell dot count flips. We are calling the count flips function over here. Cell dot count flips. What it is for column. Okay, we are calling it for column over there. Okay, so we have done we did. Okay, now we will finally return the minimum of row flips and column flips. Return the minimum of row flips comma column flips. Okay, so now let's try to run the code. It's giving some runtime error n minus I% index out of range. For I in range n equals to what length of array flip 0 for I in range n by 2. If error of I not equals to n minus I minus 1. Oh, sorry friends, it must be n minus I minus 1. Now let's try to run the code. Yeah, it's giving correct output over here. Now let's try to submit it. Okay, so basically it's been accepted over here. So this was all for today's Leetcode Biweekly Contest 136. So friends, if you have any of the doubt, you can ask me in the comment section. So thank you friends.